questions for me before we get started here? Okay, I updated the final project page on Canvas just a little bit this morning. In fact, we can go look quickly at that. Like I said, I'm trying a new color scheme here on the slides to see if that if I get a little better quality on the video. Kind of adjust the lighting and the colors and try to not wash things out. But if we go look at the final project page, so I've posted some stuff. I've kind of reworked this down here, this area down here where I've got the down towards the bottom you got the class videos. So I've posted recordings of videos we've done here in class, if you guys have noticed. So this week, right, we're in November 9th through 13th. Just want to remind you down here in red text, I've got Friday is the last day to withdraw, which what I do in the syllabus, that is Friday is the last day to withdraw, which means assignments are due. So I only grade after that day. The only thing that's you can submit after that day that I will grade will be final project material. Okay, so all of your assignments, all the Excel files, any of the quizzes, all that's going to be completed on or before Friday. And it's been that way since the beginning of the semester. Let's see, today we're going to talk a little bit about concept evaluations. We've been talking about the design process. I'm sure you guys get tired of seeing me write it, and that's okay. It's important, it bears repeating. We spend a lot of time talking about problem definition, and once you've defined a problem, you want to go see what knowledge exists for that problem. In engineering, is the application of existing knowledge to find the best solution. So we need to go find the existing knowledge for the particular problem, and then we begin synthesizing or brainstorming, put together all the ideas to try to come up with what are some viable solutions that we can move forward with. When we talked about synthesis, when we talked about brainstorming, we said there are no bad ideas at that point in time. Okay, we said there's no bad ideas at that point in time. That will come later. Well, that's what we're going to talk about today is, all right, what do we do? Because there's going to be some bad ideas in there. What do we do with those? Okay? That's what we'll do today. We'll talk about concept evaluation. And then working towards something that will work. Final assignment. All right. Now, a few other things on my update here. As I said, last day to withdraw, November 13th, that's Friday. If you want to have access to a drone outside of class, let me know. Okay? We can do that on Thursday this week. My wife and I have got an appointment on Friday. We're gonna head out of town. I'm gonna leave early on Thursday. It's not necessarily gonna impact you. I'll be here 11 o'clock. My other class, I'll leave out of there early, but I'm not gonna do any lecture that day. It's just, normally I have a day or two during the final project where you guys just get kind of a free day where you can work towards the project. This is going to be one of those. You'll have just kind of a free day on Thursday, use as you need to. I'll be here, available. If you as your group wants to meet virtually or you want to meet here, I leave that at your discretion, but I'll be here and available to answer any questions, provide access to the drones. Okay? And I'll be here during the afternoon on Thursday. I'll be up until about 4:30. I'll go meet my 4:15 class just for a minute or two, and then I'll need to head out. And then next week, right? So next week, then we'll talk about writing reports. And so on Tuesday, we'll discuss project report. On Thursday, we'll discuss presentations, and those will be the last 2 days we physically meet here. And it's Thanksgiving week after that. And then the week after that is the virtual week, the last week of classes when the report is due. And then the week after that is when we'll figure out how to do the presentations. Okay, so that's kind of where we're at. Just again, so that's documented there for you, kind of updated. Just wanted to go through that very quickly with you. Questions there? Okay, if you have questions, let me know. We'll address those. It's no big deal. Okay. So as I mentioned, we talked about synthesis and brainstorming. We said there are no bad ideas at this point. Now, we can evaluate those bad ideas later. That's what we'll talk about today. What do we do with those? Now, I pulled some notes from a text, The Mechanical Design Process by David Ullman. I've got a handful of design texts on my shelf. You're welcome to come look at those anytime you want more information. I'm sure you can find quite a bit of information online these days. But just to give credit where credit's due, I pulled notes from another author here, and that's what we'll use today. Okay, so let's talk about what does it mean to evaluate a design. Well, it's simply to try to determine which of these is the best, which makes the most sense for us. For our situation, the goal is to judge the goodness, if you will, of the design. For us, a lot of times, it's which one's going to expend the least amount of resources. What are your resources you have at this point? Well, time and money and brain power, kind of some of the big things you guys have. You do have a weight budget, so to speak, because the drone can only handle so much weight. So you do have to be cognizant of that. But what are the resources that you have? And we talked about that here. And if you've not clearly defined that, go back. We talked about the design process is not linear. You need to go back and make sure we know what are the resources. So which one's going to expend the least amount of resources and be most efficient and effective and meets the need of the client, or in this case, the problem at hand. One of my favorite quotes. Douglas Adams, writer of The Hitchhiker's Guide to the Universe, Galaxy. Like this one. The point there is you're always going to find a smarter idiot. There's a saying we like to say, you're always going to find a smarter idiot. I don't know how many times, my wife's family used to own a business, a small business, and I would kind of help out, design some things, build solutions, and early on I learned very quickly, when you look at something, you put something together and you look at it and you say, well, nobody's ever going to twist this way, or nobody's going to be dumb enough to to set their phone right next to that, or it doesn't matter, right? There's the concept of Murphy's Law that anything that can happen will happen over enough repeats, enough iterations. Just kind of keep that in mind. You will always find a smarter idiot. You'll always find somebody that when you look at something and say, nobody's going to be stupid enough to do that. Somebody will eventually be stupid enough to do that, or careless enough to do that, okay? Now, there is, for us as engineers, there's an even more important aspect to that. We always like to tell young engineers the horror stories about lawsuits, because we live in a litigious society, and that's one of the checks on, we joke about lawyers, and they go out and sue everybody, and that's how they make their money, and okay, maybe it is, but there's also, it serves as a nice check, right? It does actually serve as a nice check when a company is really careless or places profit over safety, or whatever the case may be. We always like to tell some of the horror stories of one that always comes to mind. I did a little bit of research. It's somewhat of an urban myth, but there is some fact to it. There are cases of individuals falling through skylights, right? One really famous one is an individual was trying to break into a gymnasium, trying to gain access to the roof, because who locks their roof, right? So the individual was aware that there was a roof access that was not locked, trying to break into the gymnasium, steps onto a skylight and falls right through, and was successfully able to sue the skylight manufacturer for some of their medical expenses. The reason being, the lawyers figured out that the company actually had documentation that they had shown they knew if somebody stepped on one of their skylights, they would fall through. and did absolutely nothing to mitigate that unsafe circumstance. That's the company's fault, right? Yeah, I know it doesn't seem like it's like, Steve, the guy's trying to break the law. Why is it? No, it's on the company that manufactures that good. And when they identify a safety hazard and you do nothing to mitigate that, that's on you. It doesn't matter what the user was doing or not doing in that case. You identify a safety issue, you document what you do to mitigate it, or talk to some lawyers. Be ready to talk to some lawyers. That's kind of that's what you have to be aware of, okay? I'm not trying to scare anybody off. I'm just being honest with you. When you identify a safety issue, you be sure and document what you did to try to mitigate that. That's
Wasn't that
important.
kind of the same principle behind that major McDonald's lawsuit that they knew?
Yes.
That lady that I
But-
guess she spilled
yeah.
coffee on
So,
her?
so the lady that spilled coffee on herself, the problem was it was very clearly documented that that McDonald's had received multiple warnings of your coffee's too hot. It is way too hot. Your coffee is too hot. It is unsafe temperatures. It was well documented that they knew it was a problem.
And that the corporation, I thought they also had documentation that the hotter it was, the less tasteful it really had to be because people couldn't really,
Yes.
they couldn't really judge whether it was good coffee
Yes.
or not, so they were purposely
They could
making it
use-
dangerously hot.
They could use less coffee grounds.
Yeah.
I don't know if they were able to prove that documentation existed, but that, yes, you're correct. The taste buds are less active at those temperatures, so it could be.
Or dead.
Yes, yes. Yeah, no, exactly. If you've identified a safety issue and you have no documentation, you try to mitigate it, you're going to pay for that eventually, because eventually you will find a smarter idiot. Right? So just that's a good example. Keep all of that in mind. Now, and what you guys are building with. We've intentionally selected these drones because they're reasonably safe to operate indoors, okay? But those blades still can cause damage. That's one of the reasons that once we've loaded the drone up and it's ready to fly, we leave it alone until it hits the ground and stops moving, whether you intentionally or unintentionally end up on the ground, right? That's just good robotic safety. If it's a dumb robot, we don't approach it or touch it while it's in motion. So that is a safety issue that we've got to be aware of, and that's the reason I've written the rules the way they are. These drones probably aren't going to slice a finger off, but they could take out an eye. Honestly, they could take out an eye if we're not careful, and they probably can cause laceration. So let's operate them safely. So we do need to be cognizant of that and be aware of that. Now, if we've set the safety issues aside as essentially what we call not feasibles, or we've just completely taken them off the board, what happens sometimes is once we've gone through the backgrounding and synthesis process, you can end up with a set of ideas that you as a group maybe are finding a hard time deciding between, hey, which of these should we go between? We've got 3 or 4 really good ideas. We think, one is you just build them all and see which one works the best. That's okay if you're in a really low budget scenario, but the goal is to get you guys to where you're building things that aren't always low budget. It potentially could be, it's not feasible for you to build every single option and test it. So how do we figure out which is the best one, and that's the one we move forward with, okay? Now, I don't have any magic silver bullet that's going to work every single time, but because every project's different and every group's different, all of you are going to have different ideas. We can talk in some generalities. I can try to give you some pointers and some things that will work just about every time. One thing you can do is when you've got a handful of ideas we're trying to decide between, set them all aside and look at all of them carefully. And see if you can categorize them as feasible and not feasible and what we call conditionally feasible. We're going to talk about these. For us at this point, at an introductory to engineering point, it's probably just a gut feel. Which one's which? It's probably just a gut feel. As you get further along in your engineering curriculum, you'll have tools in place where we can look at it and say, well, we're going to cause a stress point here, possible failure, or this is a really great idea, but unfortunately violates the second law of thermodynamics. You're going to have some analytical tools on board as you get in the next few years through your curriculum that we don't have at this point. So at this point, these may just simply be a gut feel, and that's okay, but let's take a good look at them. Now, if we talk about these ideas, remember I said during synthesis and brainstorming, there are no bad ideas. That will come later. This is later. This is the point where we say, all right, what are the bad ideas? What are the not feasible ideas? Now, before you set an idea aside as not feasible, always take a moment and think about why. Why are we setting this aside as not feasible? What is it? What is it that makes it a bad idea? Let me ask you something. Why is it a bad idea to kill a mosquito with a cannonball? Are we okay that that's a bad idea, right? A mosquito with a cannonball, that's a bad idea. Why is that a bad idea?
Excessive use of force, probably materials.
Yeah, excessive use of force, materials, a lot of energy, probably unsafe, right? Now, why in the world, though, if we're trying to kill mosquitoes and somebody says, well, let's use a cannonball, I mean, there's some advantage to that. It's effective, right? It's going to work. So, but it's really easy to look at that idea and say, well, Steve, that's stupid. No, we can't do that. I would suggest to you there's a company right now making millions of dollars killing flies with cannonballs. You guys seen this, the bug salt, the gun that has the salt in it, and you pump it and you basically make a little puff of air and it shoots little salt particles at high speeds? That's killing bugs with cannonballs. They take the not feasible idea and say, what is the good part of that idea? And can I change it? To where I take the not feasible portion of it and I remove it. Before you set an idea aside as not feasible, why is it not feasible? Can I change the part that doesn't work and keep the part that does? Right? Does that make sense? I love that example. I love that. I didn't have that example 5 years ago. I love that example today. Right? I don't have one of those, but has anybody got one of those? Is anybody? Are they as cool as they look, or is it just a gimmick?
It's 50-50.
Okay.
It depends.
Okay.
They are cool, but they make a mess.
Yeah.
Which is the problem. I knew
But
that
they're
company
effective.
tried to cross into like the entertainment.
Yeah.
Field, you know what I mean? Like,
Yeah.
Almost like
It's
a
fun.
kid.
Give it to the
Yeah.
kid. Yeah.
And so
Exactly.
like the parent has to clean up the soggy sugar or salt depending on what you use. You know? So I think it's short-lived.
I got you.
I'll be happy to see where it goes.
I got you. Well, they're making a lot of money. I'll give them that. All right. So, what do we have then is again, we said not feasible, conditionally feasible, feasible. What are these conditionally feasible ideas? Well, these are the things that maybe are kind of out there, or we have this a lot of times when I teach my graphics class where we're 3D printing a solution for a client. And a lot of times the client might have one solution in mind that they really want us to try to accomplish. And one of the teams has this really interesting idea. It's not what we initially had in mind, but it's going to work if the client is okay maybe changing a couple of things, or we go buy one other piece of equipment. These are feasible if one parameter can be changed. And so that comes in real handy when we're working with a client, where we say, hey, look, we know you weren't thinking about this, but we think this could work if you're willing to invest in this or purchase a few of these, or unless you just absolutely have to use this one thing. And sometimes, and some of you guys have been asking about rules. You'll have kind of these crazy weird ideas that, I shouldn't say crazy weird. You have these ideas that maybe the rules weren't necessarily designed for. It's just not clear. Hey, is this allowed? You know what? Technically, the rules don't say we can't do that. Thank you for asking. Yes, if you can find a way to do that, that's okay. That's a conditionally feasible idea. It can work. if something is maybe changed or maybe there's an additional cost. And then you've got your kind of obvious feasible ideas. These are the things that we've seen work before in something else, some way of attaching a payload to some other vehicle, whatever the case may be, right? These are things we're just almost certain are going to work. So again, you've got a set of ideas. We're trying to figure out which of these should we move forward with. Make sure we label them all as either feasible, conditionally feasible, and the ones that we just label as not feasible, we set aside after we've taken a moment and talked about and I really understand why is that not feasible. Okay, what do we do after that? Let's say I've still got 2 or 3 ideas and we just can't come to a consensus on which one should we move forward with first. Well, one thing you can do is go back to your problem definition and rewrite that problem definition as a set of yes or no questions. Is this going to be the fastest design? Is this going to be the safest design? Whatever you as a group decided was your problem definition, rewrite those as go, no go, or yes or no questions. And take all of your feasible and conditionally feasible ideas and run them through these yes or no questions. Do any of them trigger no's? Or maybe one of them triggers more no's than the others? Then we probably are going to set that idea aside as probably not the one we move forward with. And so hopefully at that point we get down to, if we get down to one idea, that's the one we move forward with. We still have, maybe we've got a couple of ideas that they were yes or they were go on all of the questions we asked about the problem definition. And then we can go one step further. We can say, all right, well, which one does all of those better? So if you take all the yes or no questions you just wrote about the problem statement and decide which of these yes or no questions are the most important. Maybe speed is the most important. And, safety is also going to be the most important, right? But maybe, being able to control the drone is important, but it's not as important as being fast. Whatever you as a group decide or is more important to you. So go through the ones that, the yes or no questions and decide which of those are more important and basically assign a weight or a score to those different concepts. And then each group member kind of actually writes down a score for how they think this design will achieve, this problem definition, and how this design will achieve that problem definition. Have each group member score those, average those, build you a table, and compare it. All right, so a real generic example here, but this group said, well, easy to use, minimal material use, those were the really important things. Finish before deadline was important, but not quite as important. And then some just other generic, I've written here, long lasting and simple design. And so you can see, they said, well, as far as importance, the easy to use and minimal material use were the highest at 30 each, 20 finished before deadline, 10 long lasting, 10 simple design. And then they just scored each of the ideas. So obviously, alternative C is the best one, but they knew they wouldn't get it done in time. Right? So based on that, then the next best option was alternative B, and they said, well, it's pretty good, it's not as good, it didn't score as high as C and everything else, but we know we're going to get it done in time. So that's the one we're going to move forward with. Just for example. Again, nice generic example for you to kind of think about. You've seen this before, you have experience with this as a student. This is what we call a grading scale, right? That's what instructors use as a grading scale. Exams are one weight, assignments are another weight, whatever the case may be, right? And then we assess a score for each of those different categories, and then at the end of the semester that all gets weighted differently, okay? There are more advanced decision matrices that you can employ. You're welcome to do a little research on the internet. It's what is a good decision matrix? All right, let's go find some good decision matrices and decide which one works best for us. You get the idea, right? Basic problem solving process applies to anything. If you need some help, let me know. But hopefully this gets you pointed in the right direction. So again, if I've got too many ideas, what are some ways I can decide from them? some really nice generic things you can do. Yes or no questions, and then weight them, and then go from there. Questions, comments, complaints? I've taken plenty of your time. I'll let you guys get to it. I'll have drones available if you need them. I'll let you guys get in your groups. You know what to do.